if needed. There we go. All right, well, welcome to class. It's now February, so we are solidly in our semester. Today we have SmartBook Chapter 4 due, and by the end of day, we'll get through most of the chapter in lecture today after we conclude with Chapter 3. It's a lot shorter of a chapter. And then Thursday, we'll do an activity around attachment. So that'll be fun. And then this weekend is your first exam. So we've talked about the exam before, so this will just be a quick review of what's happening. It opens up on Friday, basically as soon as it is Friday, it opens up, and then it closes Saturday just before midnight. So you can pick any time within that 48-hour span that works for your schedule to take it. If you're working one of those days, pick a time when you're able to sit down for a full 90 minutes or more to take the exam. As a reminder, the exam is 90 minutes long. It's all multiple choice. You do have open notes and open book, but with that time limit, you're not going to be able to search for every single answer. So hopefully you've been taking notes and you can refer to your notes quickly. But hopefully as you take the exam, most of the questions you know, and then you can flag it as you go through and go back and check those answers before submitting, and you'd be able to do that well within the 90-minute time limit. With that being said, there's 60 questions for this exam, all multiple choice. Your study guide is available. You can grab that here. Also, I wanted to remind you that this classroom, this Microsoft Teams classroom, is basically open to you at all times. So even though I might not be here in the meeting room, if you and a couple other students wanted to get together for a study group and go over your answers for the study guide, that could be a really good use of your time studying in between now and then. So one way that you could do that is you could just come here to this general meeting. So email back and forth. You can message directly through Microsoft Teams. You can also email them directly through like Canvas. So if there's someone who you've heard them make a couple comments in class and you're like, hey, you know your material, I want to have a study group with you, feel free to do that. So come here to the Teams area and you can click Meet and just start your own meeting. You can also go to any of the smaller groups and click Meet and just start your own live meeting. You can do a chat or a video chat. Hopefully you could see all that and it didn't kick me out of this meeting as I showed you. But you can use that space. Basically, each of those spaces is like essentially a classroom that you could come to and sit with other students and go over the study guide. With finishing Chapter 4, we'll get through most of it today and then finish it up on Thursday. We'll probably have time to go through some of the study guide on Thursday, but we also might not. If we go over something and it takes longer than we think, maybe we won't. But I think we'll have time to go over some of the study guide together, but it's probably best to also set your own group meeting too. So any questions about the logistics of the exam? All right, and don't forget, anytime during class, you can either use the conversation area right here or raise your hand if you want to use your microphone as well, so that we can get those questions answered quickly. All right, well, last time we stopped, the last thing we talked about was imitation and some basics of cognitive development. We talked about attention is one of the main topics, especially in infancy, that we look at. Now we'll talk about memory. Will be our first topic today. So does anybody remember the difference between explicit and implicit memory? And maybe an example of each. Feel free to either raise your hand and take over the mic or just write it in the meeting chat area too. Does no one remember implicit versus explicit from your reading? Hopefully that's because you read all of chapter 4 last week and you don't remember it at this point because it's been too long or something like that. So an example of an implicit memory is something that we're not consciously calling up to think up. And so something like riding a bike. So you know how to ride a bike because of implicit memory. So that muscle memory, that non-conscious memory of how to do something is implicit memory. So if it's non-conscious, muscly memory kind of things, how to do certain procedures is implicit, what do you think explicit memory is from process of elimination, or maybe an example of an explicit memory? All right, no one has a guess for explicit memory? Explicit memory is what we generally think of as memory. So the other day for my kid's birthday, we took them to the ice castles in Midway. There's a lot more people there than I thought there would be. So hopefully we didn't get a deadly virus while we were there. But the memories of that time, like if I think back, see them in my mind sliding down the ice slides or going through like a rainbowy ice tunnel, those kinds of memories that I have to consciously call back, the memory of an event, the like kind of like the film playing in your mind, that is an explicit memory. All right, so where did implicit memory examples go? So again, implicit are skills and procedures, how to ride a bike. Now how to drive a car is probably an implicit memory. You know where the steering wheel is, how to move your arms, where the turn signal is. Hopefully you know where the turn signal is and you use it. The brake, the clutch, the gas, the shift knob, and if you are doing a manual transmission car, you probably have a sense of where it feels like second versus third versus fourth are on your gearbox. So those are implicit memories. Now you might even be able to look back and remember if you took a driver's training course or whoever taught you how to drive, you can probably think back to that and see kind of like that situation play in your mind, like as if it was kind of a film or something like that. That is an example of an explicit memory. So I have explicit memories of when I was learning to ride a motorcycle. For me, that's a lot more recent than learning to drive a car. Actually, I wonder if I learned to drive before some of you were born. I'll calculate that myself later and feel bad about myself for being old. For right now, more recently, I learned to ride a motorcycle, so I can remember explicitly. I actually rode in the motorcycle test course at California DMVs. So I rode around in circles and figure eights and was practicing, so I can explicitly remember that. Now, when I'm riding, I don't have to explicitly remember how to do a really tight corner. I have the implicit muscle memory essentially for how to do that process. So that's the difference between these things. Usually when we're talking about memory, most people, lay people, are talking about explicit memory. Those conscious memories of facts and experiences. If you're remembering who is Piaget from reading in your book, that would be an example of an explicit memory. If you're thinking about who is Bronfenbrenner or the bioecological systems model, that would be an explicit memory. So with that being said, most research suggests that explicit memories don't actually exist until we're about 1.5 years old. So why do you think that might be? What neurologically is happening so that it doesn't seem that we can have explicit memories before about 1.5. We do make implicit memories, so like how to use a spoon or how to stack blocks. That process of how to do that, a 1.5-year-old will remember how to, say, use a spoon or how to stack blocks. But what neurologically is happening? Why can we not have explicit memories until about 1.5 years old? Thinking of the brain and neurons.
Is it because of all the change that's happening in the brain? Like you said, the brain isn't even developed until you're 2. And at that point, there's so much neuroplasticity happening that everything is changing. Is that why?
Yeah, that's very close. Really good ideas there. So you're making connections, a lot of connections up to about the age of 2. Yeah, very good. I think we had another comment as well. Or was that you that had raised your hand, Sierra?
No, I think that was Mackie that raised.
Okay. Yeah, Mackie, anything to add to that?
That was really similar to what I was thinking as well. Just the neuroplasticity, just the development and the growth of those neurons that increase the capacity in the brain to bring things to recollection.
Yeah, very good for both of you. Yeah, the reason we don't have these explicit memories is because the neurons and the brain itself is still learning how to make those memories before this time. So we do have, just like you said, Sierra, a ton of those connections being made up until about age 2, and at that point we'd start to prune a lot of those away. In that process, the brain is figuring out how to make a memory. How to wire up the neurons, how the amygdala can then send a signal to say, or no, this is where that memory network is. So up until that point, we don't really have, we're still learning the capacity to have a memory. This is also one of the reasons that we don't generally have memories from when we're really, really young. So on average, most people have memories about the time of when they were, say, 4 or 5. Fewer people have memories when they were 3, and then very few have memories when they're 2. So does anyone in this class have any memories from when they were either 2 or younger? So maybe younger than 3. So younger than 3 that they can remember and would be willing to share. And again, you can either use the microphone or use the conversation box. I mean, it's definitely possible nobody in the class has a memory that early as well. So maybe we'll just get in the chat box, just what was the age of your earliest memory? So I'll put mine was like 4.5. So about what age were you of your earliest memory? And if you put 2, I'm not going to like call on you and say, hey, you have to tell us your experience. But go for it, Mackie. I see your hand is raised.
So I can vaguely remember roughly around the age of like 2.5. It's just a really small, just essentially a picture that I can remember, but it's just me. I would carry around our family dog's dog bowl wherever I went. I just carry it around with me when it was empty.
Yeah, was that a common thing? Like, do your parents or family members talk about you doing that as a kid as well? Or is that just a memory only?
My dad's made a joke about it once or twice, but really, like nobody really brings it up all that often.
Mm-hmm. Interesting. Yeah, and so with that, we've got that about 2.5. We've got 5, 4, 3. So yeah, about the range that most people are remembering. And so that's a really good example of one of those really early memories. And then Sierra mentions it's hard to know if the memories are actual memories or something you're remembering from a home video. I have a similar thing, like looking at old photo albums. Like one of my first memories, there's also a picture of that first memory. So it's like, oh, is that actually a memory that I created because of those pictures? So let's talk about how our memories actually created and how that goes into, well, not having explicit memories till about 1.5, and then why we don't have memories till about 3, 4, or 5 for most of us in this class. Let's see. Here we've got the example of Inside Out, and I'll use that as a comparison because it's not actually that bad of a comparison for how emotions work with memories, and that's a lot of what we're talking about today. So in Inside Out, if you haven't seen it, this example might just be more confusing than anything, so I'm sorry about that. But Inside Out's a Disney Pixar movie where we've got these emotions, like this is joy here, that are kind of running the child, Riley, kind of the center of her brain. We'll come back to this example when we talk about working memory. They're essentially running Riley's working memory. So with that being said, all these little glowy balls are memories, like snippets of events. So all these yellow ones are like joyful memories. The red ones are angry memories. The blue ones are sad memories. So a big part of the movie is seeing how emotions work together in building memories and building a person into who they are. But that idea of making a memory and recording it and putting it like these little balls into long-term storage is in some ways similar to what happens in real life. As they watch the memory or replay a memory on the screen in their workspace, essentially it's reliving that memory. So reliving a hockey goal in this example, or in our examples of the memories that we just heard, carrying around a dog bowl, my memory of riding a motorcycle. So how does that memory, neurologically, how does that memory actually get created? Well, when you're a child carrying around a dog's food bowl, there were certain smells, there are certain sights that you're seeing, maybe emotions that you're feeling. And so there's a certain neural network that is active at that time when you're experiencing an event. Just like when I was riding the motorcycle, learning to do these skills, I was a little anxious and nervous, but also excited. So those were some emotions that I was feeling. The area around, like the streets, the building, the road itself, like there were smooth parts and rough parts. So all those things I was seeing, hearing, smelling, feeling, that was all the neural networks that were active at that time. Essentially, a memory is those same neural networks being reactivated later on. And let's say that neural network was using, I don't know, 10,000 neurons to experience that thing at that time. Probably more than that, but this is just an example. So when you're carrying around a dog bowl, or you're remembering you went to Disneyland or something like that, let's say there were 10,000 neurons actively participating in that one event. A memory is essentially part of your amygdala kind of recording that network. And then when you actually remember it and recall that explicit memory, your amygdala kind of says, okay, activate that network again. So your memory is actually activating maybe half, maybe what did I say, 10,000? So 5,000 of those same neurons in that same network. So you'll probably feel those same things you were feeling, or at least in part, you can kind of remember what you saw or smelt. And a lot of that is down to the connection in the brain. So we talked about axon branches and dendrites and how they can get strengthened, how we can make more axon branches, make more dendrites on any given neuron. If you remember something many, many times, those connections between those neurons are going to get stronger. So if there's something really dramatic that happens, so for example, on maybe the negative side, a traumatic memory that happens, those connections will become stronger because of the extra cortisol and the stress and other things. If it's a really happy memory and you replay it in your mind a lot, those connections will get stronger. And so it'll be easier for the mind to remember those things. So essentially, it's easier for the mind to reactivate that network that we call memory. So those 10,000 neurons that were existing and active when I was learning how to ride a motorcycle, those same 10,000, or some of those same 10,000, are what are activated when I remember that event. or when you remember holding a dog bowl. And this is one reason that, going back to Sierra's comment, it's hard to know if your memories are from home videos or actual memories, because when we say, let's say I do have a memory of going to Disneyland or something like that, and then I go and look at pictures or look at video, some of the same neurons in that network from the time of the memory are going to be active, but there's also going to be new neurons active right now as I'm viewing that. So I'm using the 10,000, maybe 5,000 of the original 10,000, but now I'm also using an additional, that was too many D's in that word, an additional 10,000 neurons. And so some of those new 10,000 neurons are going to get connected to this memory. So over time, remembering something, whether it's from pictures or from stories, you can actually change your memories slightly over time, so that your earliest memory might be now exclusively just from the pictures and stories you've been told about it. So my first memory of like climbing a burnt out tree is essentially one of my first memories, like while camping, climbing into a tree that had got struck by lightning. And so the whole top of the tree was cut off, and it was kind of like a hollow, ashy shell. So there's a picture of that. And so is my memory actually from doing that, or is it from seeing the picture? Well, it's really impossible to tell, because the amygdala is essentially activating a network, and are all those same neurons the ones that were originally part of it or not? Another big part of this, there's a part in the movie Inside Out where I used to have a shorter clip for this, but actually, where did it go? Okay, actually, we'll get to that later, on how emotion can then change our memories later on. But yeah, so keep this in mind. That's essentially what a memory is. At the neural level, a memory is the activation of the neurons and the network of neurons that was active at the time it was happening. So there's not like a single neuron that holds your first memory. With that, your first memories, there's probably fewer neurons there that are exclusively for that memory. You still were developing the process of making a memory, and then over time you've kind of overwritten maybe some of those memories as well. So hopefully that makes it a little clear of what's actually happening with the memory at the neural level. Yeah. So let's talk about language development, and then we'll come back to emotions and memories in a little while. And I've got a video to show. So with this, language development in infancy, a lot of it comes through just experience. Similar to all these things, we start to develop memories because we have more experience doing memory. We start to experience gross and fine motor skills because we get more experience. Same thing with language. So we can see these kinds of milestones here: crying and cooing, trying to mimic words, understanding words, then trying to mimic those same words. Around age 1, generally a first word is spoken, so that might be like dada or mama or something like that. So with that, language starts developing that way and just practicing it. And some of the best things here are to help a child experience a lot of different things to be able to develop their language. So it seems that we are biologically predisposed, or we've evolved the capacity to learn language in early childhood. So around 100,000 years ago, it seems that we made some neurological developments, like physiological developments in our brains, that made language possible for humans. Before that, we don't see as much evidence of like written or spoken or signed language. So it's possible this happened earlier than later, but based on the evidence, it looks like around 100,000 years ago. Might have said 10,000 a minute ago, but it's 100,000. So Broca's area and Wernicke's area are some of the most important for language. So Broca's area is here in the left frontal lobe, so like right over in this area. It helps produce words. So if you have brain damage, let's say from a stroke, this is pretty common for stroke victims, that they can still hear and understand language, but this area of their brain is not actually processing the making of language. So they can understand everything people are saying, but they can't actually express themselves through language. So that could be really frustrating for that person. Wernicke's area is back here in the brain, and this is essentially where we understand and comprehend speech versus creating. So this is the area for understanding a lot of languages. This is like making your own words. So if you are bilingual or trilingual, all of those languages are kind of stored right here in your brain. And like we've talked about, there's brain plasticity. So for any given person, it might not be exactly in this area, especially if you had some kind of brain damage or trauma or something like that. But on average, this is where people tend to develop their language. So looking at how humans develop language across cultures, Noam Chomsky suggests that maybe we are pre-programmed, or we have evolved the capacity to acquire language in early childhood. Some of the evidence of this is that the patterns for learning language, so these patterns that we showed right here, these milestones, are really, really similar no matter what language you're talking about. So children who are growing up in a culture that are learning English versus learning Korean versus learning any other language that we might see as like vastly or dramatically different are using that same pattern. So we might have this evolved capacity and this same neural pattern to learn language. And there's a lot of education research on using that kind of research and then applying it on, hey, is this a better way to teach people language? One really easy example of that is it's best to teach language earlier on in life. So a lot of schools do dual immersion programs. So starting from, say, first grade up to like sixth or seventh or even further on. So that's a lot better for learning language and getting a second or third language than learning it in, say, high school. So my elementary schools, they didn't have dual immersion programs. I tried to learn French in high school. I've tried to learn French again recently with like the Duolingo app and largely failed, honestly. I gave up recently. I was just too frustrated with my progress. Maybe not the greatest thing, but spend time doing other things. With that being said, though, a child is very, very primed or pre-programmed to be able to learn multiple languages. So I think I might have shared this example earlier on in class, but I had a cognitive psych professor who was from France. His wife was from the Ukraine, and they were living in the US. So when they had children, when he was with the children all by himself, he would speak to them exclusively in French ever since they were born. When his wife was with the children exclusively, she would speak to them only in Russian. She knew both Russian and Ukrainian, but she spoke to them in Russian. And then when they were together, when both parents were together with the children, they would speak in English to them. And so the children were trilingual just right off the bat. So we'll talk about early childhood and language in a couple later chapters, but I guess spoiler alert, for people who are learning multiple languages, sometimes they score a little lower on like English comprehension tests in, say, like kindergarten, first grade, maybe into second grade. But that's generally just because they might be using, here in Wernicke's area, maybe it's easier to access, say, the Spanish word for something or the Spanish grammar for something than the English grammar on the test that they're taking. Actually, they do a better job at, say, problem solving and math. It seems like other cognitive capacities get kind of a boost from learning a second or third language early on in childhood. So overall, people who are multilingual very early on in childhood are actually at a little bit of an advantage, even though on, say, an English specific test, they might be scoring lower in maybe first grade and maybe second grade. They're actually at a cognitive advantage. So if you have the option for doing dual immersion for children, or someone, like if you have a niece or something that's going into school, maybe something to encourage for them to do dual immersion. We started doing dual immersion for my 8-year-old before the pandemic, and then since we don't speak Spanish, unfortunately, we couldn't really support the Spanish learning, so she had to stop it. That was sad. All right, so anyway, environmental influences, ways to support language development. The more words, grammar, kinds of language that they're hearing, the better. So reading to children, reading them poetry, letting them to listen to books, different kind of grammar structures. That's the best thing to do. We often do child-directed speech pretty naturally, so a more like higher pitch and slower tempo. Oh, you found the block? Oh, that's a green block. Why don't you put that block over here? That kind of slower, higher pitch, child-directed speech actually seems to help children learn language a little better. So many cultures do that. It seems to be kind of a natural behavior that we do, and it does seem to have an improvement on children's language learning ability. Also, doing things like correcting language by encouraging it when a child is trying to do different sentences. So when you're getting closer to 2, you might be using a 2-word sentence or a 3-word sentence like dog bark. So saying something like, oh, you heard the dog barking. Showing them the proper grammar structure, encouraging them, giving them positive reinforcement that they're doing the language the right way can be really helpful. So with that, again, we tend to do these naturally, but if you're not, do try. So some of the biggest applied tips for language development is to be an active conversation partner, especially if it's hard to understand. Maybe it's hard to distinguish what the words are that the child is using, or they're using only 1 or 2 or 3-word sentences. Doing that kind of child-directed speech, narrating what you're doing. It might seem silly, but it really helps a child to learn language and learn how language is used. So similar to gross motor skills, fine motor skills, attention, a lot of language development just comes from experience. So getting more experience means a little more quicker, faster, better learning of these things. All right, so that is the end of chapter 3. We'll jump into chapter 4 now. I've only been in class for a little while, so I don't think we'll take a break quite yet, even though that seems like a good place. We'll get through a couple topics, and then we'll take a little break. All right, so your book kind of separates each age range into a chapter on physical and cognitive development, and then a chapter on socio-emotional development. The socio-emotional development chapters tend to be a little shorter because the physical development chapters tend to be a little bigger. So with that, emotion is a feeling or an affect, and they generally occur when you're interacting with something that's important to your well-being. So whether it's a threat, you might feel fear or anger, or if it's not a threat, you might be feeling like happy or joyful. So let's talk about how some emotions develop in early childhood. With that, when we're referring to positive emotions, these are things that we usually feel and experience in kind of a positive valenced way. So things like joy, love, or enthusiasm, we would say those are positive emotions. Versus negative emotions, anxiety, anger, guilt, sadness. When we feel those, we don't really like them. They're not really comfortable to feel, but that doesn't mean that those emotions are bad in any way, or that the positive emotions are necessarily good. So anger might be because somebody has wronged you, or anxiety might be because you're in danger. So that's a good thing. It has a positive benefit to you to keep you safe. Guilt is actually an example of a moral emotion. You might not have ever heard of that before. Moral emotions and moral development is one of my biggest areas of research. So with that, guilt actually helps motivate people to repair relationships. So if you've said something mean to your sibling or partner or something like that, and they feel bad, you might feel bad about having done that. And so that guilt then, even though it's not a nice feeling, it's not a pleasant feeling, it might motivate you to fix or repair that relationship. So guilt in that way leads you to do something for someone else, and that's why it's a moral emotion, even though that might not be something you would have thought about in the past. So especially in infancy and throughout life, emotions are really important to our communication. So when we are interacting with people, we get information from their emotions. We might have an emotional response to things that they say or do. A really kind of strange example of this, well, maybe not strange, maybe funny example of this is the other day, my daughter was really focused on like playing and reading a book. She might have actually been on her phone at this time. I'm not sure. She gets really zoned into activities that she's doing. But I was trying to like get her attention to ask her about school and tell her that she had done a good job, like the teacher had written her a little note, or like written us a note about like how good she did on her math or something like that. But I couldn't get her attention. So I thought, well, maybe I'll use a mad voice, because generally if I'm angry about something, they'll pay attention and then try to fix it or not. So I was like, hey, you did really good in class today. Your teacher said you did a really good job with math. And I used like a mad voice to say it. And so my daughter looked up at me and she looked a little bit scared. But then after she processed what I said, she had a big smile and she's like, yeah, I did blah, 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 blah. So I used that emotional communication to get her attention, even though I wasn't actually mad. I used that kind of communication to grab her attention. So a little bit different than it's generally used for, because generally we use those emotions to interpret what's happening in a situation. So that's why she was confused at first, because I sounded mad, but the things I was saying were not about being mad. I was actually really happy about her performance in school, and following directions. So yeah, good example there. So with this, infants learn adaptive behaviors. They learn things that work or don't work through testing things out. So if they are feeling hungry, they might cry about it. And then if they get fed, then they're like, oh, well, they learned through that positive reinforcement, oh, I can cry when I'm hungry or I'm feeling this way, and I can get the attention I need. Similarly, as social smiles develop, they might smile to other people to get some positive interaction. Maybe they'll get some more tickles or some smiles back or some more talking to them if they're smiling. So a lot of emotion is developed this way as well. So these are the specific areas that play a really big role in emotions. The brainstem, obviously, a lot of our basic biological processes are coming from there. Sensations are coming up through the brainstem. And then the amygdala and the hippocampus. Oh, yep, it is pointed out here. So the amygdala and hippocampus are really important for kind of sparking those emotions. They're not the only emotion centers in the brain. Other areas of your brain are going to affect emotions. But basically, the hippocampus and amygdala are always going to be part of that network of whatever kind of emotions you're feeling. So with that, the regulation of emotions mostly comes from the prefrontal cortex, so some of those more highly evolved parts of our brain. So we might have the amygdala kind of starting an emotion, maybe fear or frustration or anger or worry. And then our prefrontal cortex, as adults, we can kind of moderate that or manage that because we've learned over time specific techniques for maybe calming down. For an infant, they're still learning that process. This will come into play too in adolescence. In adolescence, that's about when your amygdala, so around 12 or 13, your amygdala finishes myelinating. And so it's interesting for adolescents, they actually feel emotions, more emotions stronger than they ever have in their life, because now their myelin over their axons is all there, so the messages can be sent faster, so they're processing emotions at a lot higher rate or a more complex way than they ever were in their life, versus their prefrontal cortex hasn't caught up with all the regulation that maybe they will have as an adult. So that leads to maybe risk-taking behaviors and things like that. But we'll come back to that in discussing adolescence. But similarly, for a child, they're learning how to regulate their emotions. And here we're again talking about infants specifically. So an infant has essentially no experience regulating their emotion. They're feeling hungry and maybe they cry and then they get a little calmed down because now they're not so hungry. So they learn through that kind of things. There's experience. So some of the biggest things to help children learn effective emotion regulation strategies in infancy is by providing them close to immediate support and comfort. So usually we think about regulating like negative emotions. Positive emotions, I don't think there's a lot of research on regulating those because we generally see them as like, hey, if we're feeling happy, unless it's something like mania, we don't really worry about regulating that. But anger, fear, things like that, we might be concerned with regulating, decreasing the negative impact they're having on us, decreasing cortisol levels from stress. So some of the best ways to do that for helping an infant learn are, one, distracting. So as you're experiencing an emotion, your amygdala, your hippocampus you're kind of in that state of a neural network that's saying, hey, I'm anxious, or hey, I'm angry or upset or something like that. So distracting them from something else. So, hey, look at this toy, can kind of jump to a new set of neural networks where you're no longer running through that anxiety or worry or anger. So distraction can help to do that. And it can help them learn, hey, when I'm feeling this way, I can distract myself with something. So being really active in that process of distracting from that negative emotion, that feeling of anxiety, directing towards a positive experience. So then a new emotion can start. That helps start teaching them to do that. Another thing is the attachment with a primary caregiver. Usually when we talk about attachment, we're going to be talking about the mother because that's where most of the research is done. But a lot of these attachment findings are relevant to a father as well, grandparents, babysitters or nannies who are the primary caregiver for the child. So happy positive interactions with an infant will help train its body and its brain to have those kinds of happy positive interactions reinforced throughout their life. A good example of this is that sensitive caregiving. So if a child is upset, maybe they were trying to crawl and they fell down, they're feeling sad, picking them up and patting them on the back, talking to them nicely, comforting them, cuddling them is really, really good for helping their body learn to manage that emotion. And the main reason for that is that as the brain, as these neural networks are learning to process emotions, right now it's in a state of feeling this negative emotion, feeling sad, let's say. It fell down, the baby is sad, you pick it up, and you're starting to comfort it, it will start to release, the baby's body will start to release different hormones that will decrease its stress levels. And then that helps the brain learn, oh, the pattern of when I'm feeling sad or upset or anxious, the pattern to make that go away is to release these hormones. So over time the baby learns, I need to do something to release these more positive hormones. And I mean, obviously, it's not necessarily consciously thinking that, but that's the process the brain is taking to learn this. Is, hey, I'm feeling upset, I'm feeling sad, I'm feeling scared. Oh, I got cuddled. When I got cuddled, I felt this way. Later on, they might try sucking their thumb, and they'll be like, oh, I feel a little better from that. Or playing with this toy makes me feel better. So that kind of experience. But first off, especially in infancy, is giving them that positive interaction, that sensitive caregiving will train their brain essentially to regulate their emotions well. So this is one example for crying it out. What crying it out does is it might decrease the crying at bedtime for sure. But basically what's happening, it's called extinction of a behavior. So the crying behavior is the thing that basically gets deleted with crying it out. The baby, over a long period of time, will probably learn to regulate its emotions. But initially, what's happening is the baby is learning that by crying, it's not going to get the thing it needs. It's not going to it's not going to get a calming feeling. It's not going to get reinforced. The parent's not going to come, so it stops doing that behavior. If you look at a brain scan of those children, they still feel the anxiety. They still feel the stress. The cortisol levels are still high. So even though they're not crying anymore, it doesn't mean that feeling is gone. It just means they know they're not going to get the help they need. So especially for infants, the best thing to do is to be really responsive. And I know as a parent who went through 2 kids who were really hard to get on a good pattern for sleep, it can be really hard and tiring to go in and give them that immediate care and concern. But that is the best thing to actually start training their bodies, that when they feel anxious or scared or nervous, that they need to start releasing a different set of hormones. So over time, and it will take some time for their bodies and brains to get trained in what they have to do, but then after that, they'll start to be able to do it. So that's a better way to develop those emotional regulation capacities versus the extinction of the behavior of crying when they still have that anxiety and that cortisol level high in their systems. Also, with this example, Darcia Narvaez is one of the big names in early childhood development, moral development, and emotion regulation research. So she does a lot of research and releases a lot of papers on this. But she also has a blog where she kind of spells out her research in more normal everyday language. So it's a really good example of if you are looking for a question paper or sources for your question paper, her blog would be a good relevant source versus a blog from a random cousin or something like that probably wouldn't be as good of a source. So if this is a specific question paper you'd want to go to, this is the link to that specific article, or just an example of a good web source as well as your 2 research article sources. All right, so I feel like I've been talking a lot. So any questions there about that? So that's a lot about emotions, and we'll talk about how emotions and social relationships play into things as well. But let's take a quick break. So be back at 10:52 from the break, and we will continue on in chapter 4. All right, and we are back. Let me know if you can't hear me. So let's continue on with social relationships and how that affects development in infancy specifically. So even though I'm giving examples of things that come later on in development in adolescence or adulthood, hopefully these examples help you understand the process and see how many different aspects of development are being affected at any given point. So jumping back to infancy, with social relationships, this is one of the most important places that we learn so many different things. So simply how to do math later on in life, but also in infancy, we don't learn how to experience and regulate our emotions without experiencing a variety of emotions. So trying to crawl, falling down, feeling sad, and then getting comforted. That kind of social relationship, social interaction helps us learn how to experience things in life. So this is a video I wanted to watch related to memories and emotion. So I had to find a different one. The one that I did have was longer, so this link isn't actually the one you want to go to. Basically we're going to watch it at 1.5 speed because it's more of the movie altogether versus the shorter bits that I want to focus on.
Wait, what happened?
She did something to the memory.
What did you do? I just touched it.
Oh, change it back, Joy. You can't change it back.
Oh, I guess I can't.
To go in sadness. Now when Riley thinks of that moment with Dad, she's gonna feel sad. Bravo.
I'm sorry, Joy. I don't really know. I thought maybe if
Joy, we got a stairway coming up.
Just don't touch any other memories until we figure out what's going on.
Okay.
All right, get ready.
Whoa, sadness. Sadness, stop. You're hurting Riley.
No, I did it again.
If you get in here, these core memories will get sad.
I'm sorry. Riley needs to be happy.
So if you've never seen this movie, basically these characters, joy is an emotion that controls some of Riley's actions and behaviors, and sadness is another emotion. So here in this part of the movie, and this is kind of the big arc of the movie, honestly, in this 6-minute video, Joy is thinking that Riley just needs to be happy, that all of those memories should be yellow. And this is applicable to infant development because while we do want to encourage positive emotions and have positive experiences for children, one of the things Joy does earlier that this clip doesn't show is she actually draws a circle for sadness in like their headquarters and says, sadness, stay in the circle, don't leave this circle, so that no sadness gets out of the circle. So trying to keep sadness from happening in this child's life, Riley's life, ever. And so while we might want to protect from or help when there's sadness or anger in an infant, we shouldn't try to manipulate a situation where a child never ever has those kinds of experiences. So let's watch the rest of, well, we'll skip some of this, even though this is part of her realizing. Actually, no. Maybe we'll just watch this part and not the conclusion of the movie.
I just wanted Riley to be happy.
day the Prairie Dogs lost the big playoff game? Riley missed the winning shot. She felt awful. She wanted to quit.
Sadness. Mom and Dad, the team, they came to help because of sadness. Gotta fix this. Get up there.
And so basically, Joy realizes that sadness is important for Riley's development. That Riley is going to experience sadness, and that has socio-emotional impact. So other people came to support Riley when Riley was sad. Similarly, as an infant is learning and developing, I think that gets the point across well enough there. While an infant is experiencing a variety of things in their life, so sadness, joy, fear, letting them experience those things and being there to support them in those experiences is one of the biggest things in helping their emotional and social development. So we shouldn't craft and create a situation where sadness is in a box or anxiety is in a box and doesn't get experienced, because then you don't learn how to regulate those emotions and how they can tie into other things happening. So bring people to you to help and support, things like that. So all of the emotions are really relevant and important to be felt and experienced. So we can't learn how to regulate them without experiencing them. So early on in life, surprise, joy, sadness, anger, fear, and disgust are some of the first emotions that exist. They seem to be innate. Maybe some of the reasons that the creators of that show chose most of those emotions as some of their emotion characters, because they are innate. They seem to be there from birth. Then within those first 2 years, children develop other emotions like jealousy, embarrassment, pride, shame, or guilt. So some of those have to do with cognitive development. So specifically, a lot of these self-conscious emotions, so embarrassment or pride, you really need that sense of I or me as an individual to be able to see that other people have a different perspective. And that requires that theory of mind, or a little bit of that theory of mind. In early infancy, it's really unclear if an infant can tell that they are a different separate entity than their primary caregiver or caregivers. So if they're always with a mother in the initial stages, if they're always with a mother, feeding from the mother, getting put to bed, and the mother is always there, it's really not clear to researchers if the child senses and has a conception that they are a separate being. To their experience, it seems like you can imagine that coming out of a womb, you're still with that person a lot. So it doesn't seem that until closer to 6 months and even later, they have a sense that they are a separate individual. So they need to recognize themselves as a separate individual before emotions like embarrassment and pride can even occur. Because then they understand that other people have a different perspective. So let's watch another video on the development of empathy. We've made a couple of these points earlier in the class, but hopefully this gives you a better sense of all the systems that are interacting with each other to develop empathy to its full potential. Because we see in early infants, even just being born, that if you put two infants in the same room, that they will start to share the same emotions. So if one starts having a sad cry, the other one will start having a sad cry. Or if one has an angry cry, the other one will do the same. Or if they're doing like happy cooing, they'll match that. And if you look at the neural level, like brain scans, like an EEG, you can see that the same parts of the brain are active between them. That infants can actually share the emotional experience with another child, or of another child. And then as they age, it kind of expands to young children, adolescents, adults, so that later on in life, well, even in infancy, they can share the emotions with older kids. So let's watch this YouTube video. I think I actually have it open already. Sorry about your ears there.
So you are also hit with like a wave of feelings. You might feel a little silly as you reach for a box of tissues, but it's a normal human thing to understand and relate to other people's feelings, even fictional people. We call this empathy. Empathy might seem pretty straightforward, but we know from research that it involves a complex network of brain areas that process things like emotion, thought, and understanding social cues. Many of these brain regions aren't fully developed until late adolescence or early adulthood, so it takes a while for little kids to get it right. To understand the different pieces of the empathy puzzle, scientists often divide it into 3 components: emotional, motivational, and cognitive. And to figure out how and when empathy develops naturally, researchers study how kids behave in different situations. The emotional part refers to sharing someone else's feelings. For example, researchers have tested this by monitoring brain activity as adults watch someone else's hand getting poked with a needle. And you're like your brain does things. And the brains of people watching typically show a similar response pattern to the person actually being poked. This suggests that we actually feel something similar when we see someone in pain. And it seems like this kind of empathy may develop pretty quickly. We think babies as young as 6 to 8 months show early signs of it when they make sounds or facial expressions that mirror others who are upset. Next up is the motivation.
So more other research also suggests that this is earlier too, that can happen even right after being born, that children have that capacity to share that emotional experience.
Component, which is basically the urge to do something for someone else's well-being, like wanting to comfort a friend when they've lost a pet or family member. And even though children might mirror each other's emotions early on, it takes a few years for this motivational part to kick in. When they're about 3 to 6 years old, kids might show behaviors like sharing their favorite stuffed animal to make someone else feel better when they seem sad. Now, the third and maybe most complicated part of empathy is the cognitive component. In the research world, this is sometimes called theory of mind. It's the ability to take another person's perspective, think about their experience, and understand why it would make them feel the way they do. This requires some mental gymnastics, so it's not a huge surprise that it seems to be the hardest part of empathy for young children to do well, and it's easy to mistake for selfishness or meanness. One of the most well-known ways to study theory of mind is called a false belief task. Like there's the Sally Ann task, which involves a short scenario that gets played out with dolls. It goes like this. Sally has a basket, and her friend Anne has a box. Sally puts a marble in her basket and then leaves to go for a walk. While Sally is gone, Anne takes the marble from the basket and puts it into her own box. Jerk move, Anne. After all this, researchers ask children where Sally will look for the marble when she gets back. Kids under 3 years of age will usually say that Sally will look in Anne's box because they saw the marble move, which sounds a little weird to our adult brains. From other questions, researchers can tell that kids are following the logic of the story and understand that Sally didn't see the marble move. But it seems like they have trouble understanding or expressing the fact that Sally's perspective is different from their own. Some researchers think that even if young kids might get that people have different feelings or perspectives, they can't describe it with their cognitive and language abilities. Because the brain systems involved in these abilities become more efficient as connections between neurons develop and change, by age 4 to 5, answers start to change. Basically, their brains are more able to process complex information, so more kids say that Sally would look in her own basket for the marble because that's where she left it. Now, the jury's still out on exactly how and when full-blown empathy develops, but your first few years of life involve a lot of learning about feelings and thoughts. Talking with kids about their emotions, suggesting ways they could show empathy, or even reading stories about feelings can help them figure this stuff out. And then, when they get a little older, you can just give them a good book, and also maybe a box of tissues. Also, if you happen to...
So some good examples at the end there of applied, like how to help children develop empathy. Sharing your own emotions, asking them their emotions, reading stories about emotions, drawing characters with emotions. There's a lot of ways to do that to help them recognize and understand what emotions they're having. So hopefully that goes to show you, I mean, empathy is definitely one of the most complex emotions that we have, with the affect and feeling component, that motivation that they're talking about, and specifically the cognitive component of being able to put yourself in someone's shoes. So not all emotions are that complicated. So a feeling of anxiety because you're in danger, that's a much simpler emotion, and a lot simpler to like trace where everything's happening and what's happening as you're feeling anxiety. But with that said, hopefully this gives you a sense of all the different systems that are interacting socially and emotionally as emotions develop over time, and how emotions influence any given interaction in life. So infants are starting to experience this early on in life, how the emotions work and with their lives. Interestingly, across cultures, children seem to have a basic cry, anger cry, and pain cry. Like you might be able to distinguish between your child and say a neighbor's child, like you'll recognize that. But if you hear your child and a neighbor's child doing an anger cry, you should probably be able to tell, if you've got a little bit of experience listening to them, what these basic versus anger versus pain cry sound like, because they're interestingly pretty similar across cultures. When an infant, a very young child, is angry, they'll cry one specific way, versus when they're in pain, they'll cry another way. I actually realized that I should put some recordings up in here of this. I never have, but I think I'll put recordings up, and then so I'll update the slides so there will be a link in here of recordings, short recordings, not like listening to an anger cry for 10 minutes. That'd be really sad, but maybe like 10 seconds so you can distinguish them if you've never had too much experience with children. So look for that to be updated. I've only changed a couple things in the slides in between when I put these up and now, so I don't think I've actually uploaded the newest version that I'm using, but that's okay. There's only been slight changes, but that'll be a bigger change. I will upload a newer thing. So let's talk about smiling as well. Both smiling and crying are ways that a child might display emotion and try to get social interaction. So a reflexive smile is actually a smile that doesn't happen because of an external stimuli. It's basically, you can think of it as the child just happens to smile. And this is what most smiles in young infants are. It's not till a couple months old that you can do a social smile in response to an external stimuli. So when a parent comes up and smiles at a newborn and they smile back, that's just happenstance, which might sound a little sad, but it still is reinforcing to that parent. That parent will smile more, be more interactive, and that will, over time, teach the child how to do a social smile. So a couple months old, they can actually smile back at you and interact with you with a social smile. Fear as well develops over time. So the wariness of strangers is commonly appearing at about 6 months. So if you have the same babysitter coming over, let's say twice a month, every month. At 4 months, you probably won't see any kind of wariness or anxiety, but even though this is the same babysitter, at about 7 months, you might see the child interacting with the babysitter with a little bit of nervousness, not wanting to go with them. They might also protest when the parent is leaving, and you might see that until probably about like the kindergarten years, up until even age 6, that they might have a separation protest. That's often some of the biggest struggles with the first steps of going to school, is that kind of anxiety of being separated. But that really starts to appear at about 6 months of age. And also seems to be lining up when the child is starting to recognize that maybe they are a distinct entity, that this maybe at first it might be that they're thinking like a part of them is gone with their immediate caregiver, but then they're starting to also realize at this time that they are their own individual, separate from others. That theory of mind we were talking about earlier. So with this, over the first year, the infants are developing this ability to inhibit or minimize the intensity of their emotional reactions. And a big part of that is the caregiving of a caregiver, how responsive they are, how quick they are to help soothe, and how effective they are at that. Some behaviors you might see in a 1-year-old might be thumb sucking. Once they're able to talk, they might babble to themselves or talk to themselves. Those are some coping strategies that children might use to reduce the intensity of maybe fear or anxiety or sadness. So infants, very young infants, depend exclusively on the caregiver. Like we've talked about a couple times today, they don't yet have the capacity to regulate their own emotions. They're learning that capacity. So by giving them cuddles and care and concern and being really responsive, that helps reduce their arousal level. And we're talking about arousal level. Usually we're talking specifically about the cortisol levels, the stress hormones that are in their bodies that are leading to a lot of these emotions. So helping them decrease those stress levels teaches them a pattern that their body, when they're feeling this stress, to decrease it, they need to release these hormones. So they can learn some behaviors like thumb sucking to do that and release those hormones, or distract themselves, things like that, to learn to regulate. But they need that process, they need that experience to be able to do so. And they need the caregiving to be responsive to do that too. So again, there's that link we talked about earlier. The context matter around emotions as well. So fatigue, nausea, or fatigue and hunger, they might make a child act with different emotions than they would have had otherwise. My children do this a lot when they get hungry. I can tell that they kind of require snacks like every 2.5 to 3.5 hours. Otherwise, they get really grumpy. So that's like between meals as well. So if I hear them being really mad at each other, it might be that they just got in a fight, like one stole the other child's toy, but it also might be that I passed that time and I didn't give them a snack in enough time. So I try to teach them, hey, here, have this snack, eat this granola bar right now, or you're going to start getting grumpy soon. Usually if they're in the midst of playing, they're like, no, I don't want to eat right now, I'm not hungry. And then they get grumpy and I'm like, oh, well, go take a break in your room and here's a snack while you're there. So trying to teach them to regulate those emotions and realize that the context around them are affecting this. That when they're hungry, when they're extra tired, when they wake up at 4:30 in the morning, all of us are pretty grumpy. Infants are learning that. Young children are learning that. So the context of mothers with depression is an area that's been studied a lot too. So this can be postpartum depression. This can also just be clinical depression sometime in early childhood. So one of the symptoms of depression is a lack of motivation to do things. And so it turns out that mothers who are suffering from depression, and this applies to fathers as well, are less likely to rock and soothe their babies as quickly, like as responsively, or as much. So this often leads to less effective coping for the child. The infant doesn't learn as good of coping skills, which in and of itself can lead to a higher likelihood of suffering from depression later on. And there's also the genetic component that a parent who suffered from depression, it might be because they have the genetic predisposition that then got activated. So those genes might have also been passed off to the child. So it's some of those correlations there. Does one cause the other, or both causing each other? That kind of thing. So especially for, so that's one reason treatment is so important. And knowing about this, even if you are suffering from depression and you have a child, you can know that this is one of the symptoms. You might not want to or have as good of motivation to go and do that, even if you know you should. So I hope nobody feels guilty about suffering those symptoms of depression, but maybe that can even change the behavior or lead people to seek treatment, so that cycle doesn't continue in that way. All right, so that is, I think, a good place to stop, even though we've got a couple minutes. Temperament and attachment are basically our last topics in chapter 4, and we'll do an activity on attachment next time. I guess we'll do a quick overview of temperament, then we'll go into more detail next time, but we will probably end a little bit early. So temperament is basically, you can think of it like infant personality. There's 3 main types: easy child, difficult child, and slow to warm up child. For an easy child, generally an easy child, especially in infancy we're talking about here, has a positive mood, can establish routines really easily. So let's say you take this infant from home to grandma's house for a weekend trip. Maybe the first night might be a little struggle, but the second night they're right back in their normal sleep schedule. They set that routine really easily. They adapt really quickly to new experiences. Versus a difficult child, their general interactions and reactions to things are more negative more often. They might cry more frequently. Not that they're always having negative interactions, but that it's more often than an easy child. And this is one of the key defining features, is that their daily routines are harder to set. So for this child, take them from home to grandma's house, they're going to have a hard time the whole weekend. They're not going to be able to reestablish that routine. The change is going to be really weird. They'll probably have a lot more hunger grump times where they're not eating well and their schedule's all messed up. Slow to warm up child, you could kind of call them a boring child. I mean, you wouldn't want to do that to like your sister who your niece or nephew is like boring to you. But generally this child has like a lower activity level. They don't really do too much. They might have a somewhat negative mood and a low intensity of mood, but they don't really have a bad time setting routines, but it's not very good either. So just kind of a lower intensity level, just generally. So those are the basic personality categories for temperament: easy, difficult, and slow to warm up. So we will talk more about that and then jump into attachment next time. Let me know if you've got any questions, and I will see you again on Thursday. And don't forget to be working on your study guides for exam 1.